Welcome, everybody.
Lord. Okay.
Welcome, everybody, to the America's RIG, the RedHat Research Interest Group. It's nice to have you with us. We are recording the presentations today, so if you do not want to be recorded, then you should not stay. We have two students doing presentations today from both the graduate and undergraduate community at Boston University. Arlo Arbelli is going to present first on our open source education project, and Ethan Klein will present after that on the unikernel Linux and security project. So they're both really interesting and have a fair amount to say. So I am not going to go into anything further so that there's more time for Q&A. So Arlo, if you want to start sharing your screen, take it away.
Cool. All right. Let me get that going. Sorry, there's oh, I'm sorry, I lost my Google Meet window as soon as I okay, can you guys see my screen? Anybody?
No.
Yeah, so I can see it, but it's very tiny.
Okay, with these monitors I can never tell.
You wanna use the share my screen from the Google app.
Yeah, I'm just trying to get the right desktop on here.
Okay.
Okay.
That looks like you're doing the right thing now. Yep.
Okay, here we go, and if I play it, can you guys see my speaker notes, or is it just the screen that you can see?
Yeah, we can see the speaker notes and everything.
Oh God! I should have figured this
All
out
his
first.
secrets are revealed.
Oh no! I am so unfamiliar with Keynote.
It's open source at its best.
Yeah. All right. I'm just gonna do it so that you guys. How about now? Do you still see the speaker notes?
No.
Am I not even sharing
now it's back
anymore?
to being a tiny screen again. Sorry.
Everybody can pin the screen if it's tiny.
Still trying
Exactly. That's what I was trying to say. That we can pin the screen and we can go on.
Oh, I'm so sorry. So wait, is it better like this or no? Still tiny?
I don't see it in the tiny screen. Where should that be?
Oh, okay. Let's see.
Yeah, what you did before,
I'm
where
so
you
sorry.
shared your screen using the Google app, was better.
Oh, what? Okay. Ali's here to help me.
So turn off your screen sharing and start the sharing again, or everybody will have to pin the screen manually.
There you go. You got it.
How do I get my speaker notes so that
this thing is being shared? So maybe move this thing there and move that thing here.
No, it's working.
Now it's just presentation mode. We can't see your notes anymore, so that's good.
Okay, great. All right. Sorry for the delay. I think we're good. Yeah.
Okay.
Thank you so much. All right. Without further ado. So today I'm going to be talking about the open source education project that I worked on this summer under RedHat Collaboratory student grant. And we are calling this presentation Dispatches from the Rocky Road to Open Source Education, because of course, while a lot of effort goes into developing these tools, there is a whole other beast that is actually deploying them in these live classroom environments as we've been doing last semester and this semester. As you might have seen in my speaker notes on my first slide, because we're calling this dispatches, you'll have to bear with me because I did go find radio dispatch codes that accompany most of the slides. So if you want to give me a pity chuckle, that would be great. All right. So for code 1012 preliminary report, I'll just talk about a brief overview of what this presentation entails. So first I'll talk about just a little bit of the timeline of how we got to where we are, the inspiration for this project, and I have my obligatory David Byrne gif there for any talking head fans. And then I'm just going to do a quick overview of a couple like big projects that pushed this effort forward over the time that I was working on this Collaboratory project. And I'm going to finish off with our actual lived experiences of deploying these tools in our like very large systems class last semester and this semester, and how that kind of informed both current work and the future work for this project. Okay, so for my Code 1014 progress report, this is kind of the timeline of how we got to where we are with the OP project. So this all started with Professor Cravella at BU and his CS237 textbook, which served as a huge inspiration for how we moved forward. And Professor Cravella used Jupyter books to create static in-class textbook and lecture content. And that was a huge inspiration for Professor Apavu's computer systems textbook. And a lot of our effort in this project has kind of centered around this specific use for this tooling for computer systems education. But as we kind of experience working with these tools, developing an environment for both authoring high quality, open source and accessible computer systems education, we started to think, how can we evolve this from our specific use case and our one instance to something that can actually be used by educators, both within computer systems and outside of that, and how we can make these tools accessible and leverageable for actual like use for educational content. And so from there, we have started to, we have this kind of, this timeline is definitely an oversimplification. We've both moved forward on the work in the Under the Covers Secret Life of Software book, while kind of trying to pull out the more general techniques that we've used there into the OP infrastructure, which I'll talk about in a second. And at the same time, tried to merge some of that work back into Professor Apavu's book. And Professor Krieger has actually started working on an operating systems textbook that is a product of the OP work that has been done. So he's had the privilege of hopefully avoiding some of the bugs that we've had to deal with but not all of them. So I know Iran has had his also struggles. Sorry, 1 second, I need some water. So yeah, that is kind of how we've gotten to where we are and the inspiration for this work. And so like, what actually is OP? So we've tried to kind of templatize a model for enabling an environment that it combines produced content, so like authored textbook, lab manuals, lecture slides, with the software that enables both authoring of that content and gives an environment for students to interact with the content, and also to have an accessible environment for learning about computer systems in our case. And a lot of that for us has been specific to creating a Unix environment that is as realistic as possible for the students to like do their assignments, interact with our textbook content, use live examples. And outside of our specific computer systems use case, we want, our kind of goal is to leverage open source technologies to have an open environment that's not beholden to any like proprietary software, so that educators can both collaborate on, publish, and operationalize just high quality materials, and so that students have prioritized access to that in a standardized manner. So that's our kind of ethos here. So now I'm going to talk about a couple of the projects that have actually kind of brought this goal to life. The first of which I'm calling Code 909B, Road Blockade. So through our experience with using these tools for in-class actual lecture slides and presentations, we reached, of course, a versionitis problem that we're all probably familiar with. A huge dependency for our lecture presentations is a RISE extension for the Jupyter environment that this kind of infrastructure is based off of. And this was only supported in the deprecated Jupyter Classic. So we kind of hit a real roadblock that was, how do we actually use the lecture material that we've created as we're moving away from this deprecated version? So we were wondering if there was a path forward for bringing the RISE functionality to Jupyter Lab. And that was critical for us actually bootstrapping a semester of a class. We need to have lecture content. So a Red Hat intern, Yixin Zhang, with the mentoring of Danny Shi, took on the task of bringing RISE compatibility to the updated Jupyter Lab environment. So Yixin actually created her own fork of RISE that Professor Apavu and Professor Krieger are both using to present their lectures in class every week. So that was a huge impact of this work. In addition to actually just making RISE functional, there was a lot of work on her part done to enable really cool interactive elements that make this really useful for the lecture environment, such as a chalkboard feature where you can write on your lecture slides, it live in class, enabling a black theme for, aesthetics, those of us that like it dark, and other useful things like being able to hide controls while we're presenting, the kind of things that we expect from a slide-based presentation environment that we sometimes we have to work to integrate when we're dealing with the sacrifice between open source and accessible standardized environments. And so there are a lot of outgrowths to this work. There's ongoing work on getting a cell layout template. So kind of like how you would expect in PowerPoint, where you can just kind of click and get a slide template that makes sense, that's easy and user-friendly to interact with. So we're working on building that kind of template infrastructure on top of the RISE and Jupyter Book lecture creation that is currently being used. And then I've got just a nice little screenshot of the kind of integrated lecture experience that this lends itself to. So while we have our lecture slides that we're able to present and interact with in one pane, because we're doing this all within our Unix container environment, we can also have a terminal on the side and be able to open up many terminals, actually interact with the Unix environment and do live demos for the students, and actually be able to do some live explorations that are really important for really understanding these concepts at a deeper level. And like I said in the beginning, a lot of this is tied to the coordination of content, software, and services to enable this kind of work. So this really kind of focuses on the interaction between the content that we want to present and operationalize, and the way that software versions and the kind of software that we use both enable and inform how we author and deploy such content. So that was that work. The next project I'm going to talk about is the work on both on bridging the gap between the now software that we are running in this environment and the services that we deploy it on. So we have a lot of software that's required to standardize our deployment of services. And there's a lot of software that we require to actually is in our specific computer systems case to build a Unix environment within Jupyter Lab, which creating a real life terminal environment isn't really what Jupyter was meant for. It wasn't the intention of that software. So there's a lot that we have to do to really carefully curate that environment. And a big part of this model is that we need to have these pathways within our environment for both supporting the authoring of the book, lecture, lab content, and also to have this student environment that looks as much like just a Unix terminal as we can, to really give them an interactive place to put these concepts to work. Yeah, so our experience with working with this kind of image curation taught us a lot of things, and one of the big ones was we need to be deploying these in various different environments. So the way that it interacts with the service that it's deployed on is really important, and as that changes, we want to guarantee that we have consistent and consistent and working performant versions of these containers. And in the way that in the OP infrastructure, we also have the notion of a container branch for every book, so that in every so that for every instance of a book that is spawned from this template, decisions can be made to design and construct content that goes into this container that is both specific to your service and also specific to the kind of content that you want to host, and the kind of the educational content that you want to support within that environment. And this is also all based on make and open formats to be consistent with our not wanting to be beholden to any proprietary formats. We want this to be open and accessible. So we have a lot of requirements for what these containers need to look like, what our build and deployment environments need to look like. So a Red Hat intern, Aberami, did a lot of incredible work towards getting these the build, the deployment, and the customization project up to customization process to where we needed it to be to actually have these working for both students, authors, and professors. So Aberami did a huge exploration of all of the issues of how we standardize container definitions. So kind of documenting where those customizations take place, how one actually builds and includes all of the necessary software for the container that you need. And she did a lot of work on so we had our kludged together container environment for our one-off computer systems class, but a lot of that was very specific to creating a Unix environment for that computer systems content. And there was a lot of work to be done to generalize, to pull from our kind of exemplar and figure out what is the bare minimum that needed to be included for the OP template to just be not specific to our case, but to be something that could be generally useful and then be customized for whatever use case somebody needs. And at the same time, we were also running a 250 student class. So she was also tasked with working out a lot of the bugs that we encountered with ensuring that we have a normal Unix experience within our containers for the students to be able to rely on. Some of those things include permissions issues with our home directory. Depending on the service that we were deployed on, there's different interactions between GID and UID that needed to be sorted out. And also minimizing these image sizes, because as we are deploying these in a 250 student class, when we were having deployment times of 20 to 30 minutes when those images weren't cached, that is a huge, when we're in lecture and discussion, we need those things to be brought up on the fly and be ready. So Aberami did a lot of work on making that viable and getting those image sizes down to a workable place. And she also did a lot of work towards developing a Fedora-based container in addition to the Ubuntu Jupyter stacks that we have currently in use, and did a lot of exploratory work for the different ways that we could automate the build and the deployment process using a lot of different platforms. Next project I'll talk about, I'm calling Paramedics Dispatched, because this relates a lot to the testing infrastructure that we realized very quickly was very necessary for being able to rely on consistent content, the way that it was displayed, the way that things built, the way that things ran. So like the effects of the software and service interaction, whether it's software versions, the software that's included in these images, had a huge impact on the correctness of the content that was being hosted. And we've learned that the hard way as we'll be in the middle of the semester, and as updates come through, things can break, and they can break without us even knowing. So we definitely had a need for a testing framework to make sure that things behaved as expected. So Jinyi did a lot of work with also being mentored by Danny Shi to create a template book. So an instance of one of these books that includes a lot of the features that we use in our content generation. So a lot of the interactive content, different types of cells, different ways of displaying things, tables, things like that. And she did a lot of work for actually verifying through both automated tests through GitHub Actions and also the roads testing infrastructure to verify that certain important things like the way that both static and dynamic content get displayed, these issues of folder permissions and control over access to persistent storage, which is very important for authoring, but something that we might not want polluting the student's version of the environment. So a way to kind of make sure that all of those things are working as expected through different iterations of both software and service. And at the same time, this test book also served as a really great template to be an exemplar for authors on how to actually instantiate certain elements within their content. So the same things that we were testing for correctness served as a really great template for integrating those things into new authored books. And so the way that all of this work has kind of come together to help us support this huge computer systems class, I'm calling code 1015 Pursuit and Progress. So the kind of second half of the battle is really putting these tools to work in live classes. All of this work has come together to enable a lot of these features that we uncovered as being super important. But in these huge classes and in actually putting things to the test, that's always another story. And that's where my role in this effort really centers around. And my last dispatch code I'm calling 918 escaped mental patient, because of course any experience as a graduate student running a class of that size will drive you crazy. But so my work really hinged on like identifying the requirements through living through the deployment of these tools for like that really informed the goals, the current development of like the current directions for the project and what our priorities were. And we learned a lot of things that really did change the way that we saw and interacted with a lot of these tools. And that involved on my part a lot of like on the fly debugging as we would, in a live classroom setting, if you run into a hiccup, that can quickly become devastating. So as we uncovered these problems, kind of coming to quick solutions and changing course as we needed to. Another big part of the work that I did was actually using the tools for content creation and figuring out best practices for working with this infrastructure, figuring out what the like best use cases for a lot of these tools that we built up would be. And so that a couple experiences that I think are valuable to share here. While it might seem like very exciting that we have all of these really cool tools for interactive content creation, the ability, for example, to embed a terminal inside your static textbook and allow students to be trying out exercises right within the text, within the reference material, we found that actually going overboard with some of these interactive tools was actually distracting for the students and was less helpful then creating certain static, like consistent content while providing the environment separately, kind of intellectually separately, a clean Unix environment for the students to engage with. So as we kind of went through the semester, we ended up developing a different strategy for our lab manuals. So rather than having the like interactive content that we thought they were going to be, we ended up switching over to finding a method for using Jupyter notebooks to create just standalone static content and distributing repositories that had accompanying code and exercises for the students to work through, supported by the reference material that we provided for them. Another huge issue that another experience that really dictated how we proceeded in the development on this project was realizing that the in the deployment of these images for students to use as their development, as their learning environment, like I mentioned before, we found that having 20 to 30-minute deployment times when you have 250 students trying to access the same service was really detrimental to like in-class instruction time. So one of the things that became a priority and key is actually working on this semester is having a tool that we call the stretcher for being able to pre-fetch our images, cache them, and have nodes allocated when we know on a schedule that many students are going to be requesting these resources. And those are the kinds of things that we only really encounter when actually putting this stuff to the test with real classes, with real students trying to access them. So coming to solutions and strategizing around how to solve these problems as they come up was a huge kind of theme over last semester and this one as we put these tools to work in real life. Sorry, I lost my speaker notes for a second. Yeah, and additionally, so figuring out the best way to kind of curate these environments for the students to get the most use out of them. We found that like instead of giving them this kind of full-fledged Jupyter hub environment, that we found actually to almost distract the students from the core concepts that we wanted them to be interacting with, being able to strip down, and I believe Abarami contributed to this work as well, being able to strip down and customize by removing plugins from our Jupyter hub environment so that there was nothing but a terminal, no file explorer, no fancy gadgets, just a bare bones environment for the students really helped to make that experience more straightforward for them. So yeah, it was definitely a huge learning experience putting in the live deployment of this tool, and that will, as it has continued, as it has structured our work and development on this, it will continue to do so. And it will continue to inform how we create and distribute this tool, both for our purposes for computer systems education and to try to make this a more general, accessible thing for educators and students everywhere to leverage. And I believe that is my last slide. I'm sorry I've been so flustered, but I would like to say, but there was meant to be a thank you slide in here, but I'd like to just give my thanks to Professor Jonathan Opavu, who is my advisor, Aran, Heidi, Larry, and all of the interns that worked on this project that were called out here, Abarami, Zinni, Yishin, and Danny, who was mentored them as an engineer. And yeah, that is all. I hope you enjoyed my presentation.
Thank you, Arlo. That was great.
No problem.
One thing you didn't mention, though, was what did the students think about it? What was your feedback from the students, aside from driving you crazy?
Oh, aside from driving me crazy, so I think a lot of, well, a lot of the craziness is just students not wanting to interact with something that they are new to, which, you know, learning Unix is difficult for everybody. So regardless of the environment, that was going to be a little bit difficult. But especially our better students really like were so engaged and like really, I think, benefited from being able to like put to practice and have like a consistent environment that we knew from like was tried and true from the development of our assignments, of our text. Every example that we gave them, every exercise worked as we expected it to when we were developing it. So I think the students definitely like benefited from having that consistent, trusted interface and experience. And yeah, I think a lot of them, especially the more engaged students, really were like thrilled and floored to be able to kind of like get in there. I think like the most heartfelt things for me were when students like would show up to the office and be like, wow, this seemed impossible, and like I just did it, I watched it work, like I feel like I actually know what I'm doing. So I think that's like such a valuable experience for them, and I hope they agree.
That's very cool. Did anybody else have any questions for Arlo? Okay, that's good because we want to make sure that we have equal time for Ethan. So Ethan, Arlo, you can drop your presentation connection. And
I did I pressed stop sharing.
yeah, you're not sharing large anymore, but you still have a second connection. That's your presentation. So
oh,
you can leave it there.
How
It's
do
not hurting, but you can get rid of it if you want. Ethan, why don't you start?
yeah,
sharing your
I've closed Keynote. Yep, sorry.
Here, maybe I can kill it.
Yeah. Sorry, everyone. I'm running on very little sleep. I hope I wasn't too flustered.
Right.
Okay.
Can you see my screen?
Yes, we can. Thank you.
All right. Okay, so hi, everyone. I'm Ethan Klein, computer engineering undergraduate. And today I'm going to be presenting on two of the projects that I worked on this summer, one being unikernel Linux, and the other is the secrecy project. Before I begin, I would like to give special thanks to my supervisor, Professor Oren Krieger, and to my mentor, PhD student Eric Munson. I'd also like to thank RedHat for this amazing opportunity. So to begin, I'm going to focus on the unikernel project and the work I did on it with interrupts and the library liburing. So to start off, what is unikernel Linux? Well, unikernel Linux, or UKL, is a project designed to create a massive performance improvement on a program by moving the UKL linked program from user space and into the kernel space. By moving the program into the kernel space, the program can avoid major performance limiters like system calls and interrupts. So just a little bit about the motivation behind unikernel Linux. So unikernel Linux is not the first unikernel operating system. Others have been created before. However, these systems have usually been built with specialized operating systems instead of general purpose operating systems like Linux, Windows, and Mac. What makes UKL special is that by patching Linux instead of using one of these specialized operating systems, the UKL linked programs can experience the performance improvements that you find in a unikernel design, while also keeping the hardware acceleration and all the standard development tools of Linux. Other unikernels generally can't offer these features. So in my work over the summer, one of my responsibilities was to analyze the number of interrupts generated when running a message passing program that was linked with UKL versus when it was not linked with UKL. To do so, I created a program to reveal the number of network interrupts that occurred during the execution of this program. The program pulled the number of interrupts on the network card before execution, and then after execution of the message passing program, and it took the difference between the two to find the number of interrupts that occurred during the run of the program. And my analysis revealed that there were some incredible performance improvements that were shown by the UKL linked program versus the baseline. So in the graph on the right, it's shown that the number of interrupts that were generated by the message passing program when run without unikernel Linux, which I refer to as the baseline, were much greater than those of the program when run linked with UKL. As you can see, I found a dramatic drop in the number of interrupts, with just about 6% of the original interrupts being present in the UKL version. And while me and Eric haven't come to, or we're not completely certain of what caused all of these interrupts to, like what happened to all of the interrupts, we theorize that it has to do with the relationship between the speed at which interrupts are generated and NAPI. NAPI, or New API, is an abstraction created for easier interaction with the hardware. And one of the features of NAPI is polling mode, an interrupt mitigation mechanism activated when the network card is sending too frequent interrupts to the kernel. We believe that when the program was running in UKL, the device was able to stay in this polling mode because running the program in UKL generated these interrupts on the network card at a significantly faster rate than the baseline. We believe that the program rarely exited the NAPI polling mode, which is what allowed it to have far fewer interrupts and overall much faster performance. When running these experiments, we also wanted to make sure that the baseline was as optimized as possible to ensure that our results were as fair and to demonstrate that the UKL version is truly the faster option. So to do so, I implemented liburing into our program's TCP stack. Liburing is a library which uses kernel threads to process sends and receives. And this method is actually somewhat similar to UKL in that the program can avoid many of the associated system calls from doing standard sends and receives. Doing so also allows liburing to exhibit a much faster performance than standard network code, and is generally what I would consider to be a much fairer comparison to UKL. And while the baseline did see the major performance improvements from using liburing, it was still significantly slower than the same program run when linked with UKL, demonstrating that UKL can still enhance the performance of any given application more than something like liburing and other more standard tools. The other project that I worked on this summer was the secrecy project. So secrecy is a multi-party communication program that allows many parties to combine their data for analysis without the risk of leaking sensitive data between them. Secrecy has many applications in big data when privacy is a major component of analysis. And for example, it would be useful for medical professionals to be able to share information on their patients' medical conditions. However, due to the existence of HIPAA, sharing information about would be a criminal violation of patient privacy. So by using secrecy instead, these medical professionals could combine their data for analysis without letting each other see the individual medical records, thus protecting the patients and the professionals. So a little bit of the motivation behind secrecy. Although secrecy also isn't the first multi-party communication program, it does offer some unique logical and physical optimizations, including query performance, or improving query performance by making, or by many orders of magnitudes. Secrecy is also being designed to work well inside of unikernel Linux, meaning that these optimizations could even be great, or could see an even greater performance improvement when linked with UKL. These optimizations also allow secrecy to reduce the execution cost when the program is outsourced to third parties like cloud providers and data centers. So while I was working on secrecy, my main focus was on their TCP communication layer. The secrecy team had recently migrated the project from a C implementation to a C++ implementation, and they were looking to add a new communication layer to the program using TCP. They had other optional communication layers that they had been using previously, but these were using external libraries, and they believed that there was room for kind of finer tuning using our own stack instead of one of the others. While working on this, I was working with a master's student, Ian Saucy. The two of us came up with a design for this new communication layer. The design needed to be able to multiplex messages from any given thread on a machine and send them across the network to another corresponding thread on the next machine. And although the overall concepts of our design were fairly simple, the multi-threaded and multi-system nature of secrecy created some extra complexities revolving around message ordering and coordinating the time and doing the coordinator timing. So to better understand our design, we came up with a diagram that you can see on the left. If you start at the top left, you can see a function call would be made in secrecy called send shares, and this would load the corresponding send buffer just to the right of that with the given metadata and data of the associated shares. The TCP coordinator thread would then pull the send buffer and read the messages of each thread, sending them to liburing to be processed in the kernel and then sent to the next machine over the network. The next step would be on the other machine to have liburing read in these incoming messages and pass them to the received buffer of the expecting thread. That thread would then call receive shares to read the messages from the associated buffer. Ian also came up with the idea of using atomic variables for this design to come up with a more lockless design. And this was kind of necessary for us to experience the same performance that they were seeing in the other communications layers. So why does our design need a coordinator thread? Well, when designing our communication layer, we realized that early on, each thread was going to have access to all the necessary sockets. This would be extremely intensive as each device in the communication ring has a lot of threads, and each of those threads would need to have a different socket for each thread on each machine. So instead, we decided to centralize the sockets onto one coordinator thread per device. By combining the sockets into this one coordinator thread, we could divide the number of necessary sockets by the number of threads in the execution of the program. Another subject Ian and I were discussing was zero copy reads and writes in our TCP communication. A zero copy read or write would mean that the system would track the original location of data rather than making a copy of the data received or to be sent. For us, this would mean that on a send, memory would be transferred directly from the application's memory to the I/O device. This would result in improved performance and reduced memory usage. However, unfortunately, Ian and I faced some setbacks in our communicator development, and we decided to, due to limited documentation on liburing's implementation of zero copy, that we were going to postpone the implementation until the rest of the system was working better. However, in the current state of the project, it's seeming more likely that zero copy will be added moving forward. So what else is coming for UKL and secrecy? Well, before I mention any future improvements, I wanted to congratulate my mentor, Eric Munson, and the unikernel team. The project's paper was just recently accepted to the 2023 EuroSys development conference. Eric also explained to me that going forward, he's looking into trimming the latency and event handling by writing the events to the UKL linked application. And Eric is also looking into making the massive reductions in the number of interrupts that we experienced in the message passing algorithm more generic. Although UKL offers great improvements in the network communication, seeing this dramatic drop in interrupts more consistently could give UKL an even greater edge on any competition. As for secrecy, the implementation of the TCP communication layer is still a work in progress. Although the design that Ian and I created will remain essentially the same, the code is currently being rewritten to be more modular. And by making the design more modular, the team hopes to make the code more testable, and by testing, less prone to bugs and errors. Again, I want to thank RedHat for this opportunity and take this time to answer any remaining questions.
Yeah, Tom has a question. Go ahead, Tom.
Yeah, this is more on the, I guess, kernel side. So you mentioned interrupt latency. Have you looked at using the RedHat's RT kernel. That uses a preempt RT patch set.
I have not.
I think that might be of interest. If I think one of the things that we try to chase is reducing the latency between interrupts, so we have a much more predictable. So I think the combination of just removing the interrupts altogether and then making them more predictable might be a compelling use case for someone trying to solve some difficult real-time problems.
Yeah, I think that would be interesting.
Tom, are you thinking about perhaps combining UKL with the RT patch, or just testing the RT like regular kernel and user space against UKL and against sort of regular Linux? I'm not quite sure which one you propose.
Well, I think as you're running these experiments, we're trying to solve similar problems with the RT patch set, and I think you might have a chance of like getting the best of both worlds. So I'm just suggesting maybe extend your testing to the preempt RT patch set. See if it improves things. If it doesn't improve things, but say your baseline is better than the real-time patch set, that would make a case for why are we even using the real-time patch set. So either option is mostly just throwing out there an idea of another variable to try. And I'd really like to know because some of the so when you mention things like network latency and that sort of thing, that's the sort of thing customers really are interested in, like how tightly you can couple things so you never miss anything. I'm really interested in like low latency and high throughput sort of applications. So
it is important to say that the UKL use case is slightly narrower than just like a general kernel, because you are linking, you're linking the application with the kernel, which is a little, it's a little bit different from what you're doing. But I think it would be really interesting to sort of look at like all four combinations, because UKL is just a patch set against Linux, so it would be possible to actually combine UKL and preempt RT, and also test the application running on preempt RT and also the application running on Linux, and the fourth combination, which I've forgotten there. But all four combinations like that.
Yeah, right. So some of these use cases we have this general OS, but people only care about one application. And for sort of our telco customers, they're running some DPDK application, which is a sort of a poll mode driver that they're running just to get rid of those interrupts. And if you could show like, okay, here's this DPDK application that's doing poll mode interrupts before and after, then you could make a case of like, okay, you only care about the application. We're only going to give you the application, but you get this huge win, so go crazy.
Tom, that's awesome. Like one of the things I think we've shown advantages for certain data center workloads. What we're actually looking for is kind of killer apps that would help motivate the design, that help motivate this for real kind of users. And I think that example of sort of having an application which is critical for an application environments where they're only running one application that's critical, although they want all kinds of other dog and cat applications. And the whole idea of using DPDK and programming with a totally unique solution in the user level stack that loses all the value of the general stack, we're trying to see, can we get the same kind of performance while not sort of re-implementing networking in user space, which just
Right.
seems wrong.
Right. And I think a follow-on question is, like, usually the machines we have, like 128 cores, could you run 128 instances of this, your
Secrecy, or
no, I'm all about
UKL.
I'm all about the
Yeah.
I'm going to call it microkernel, because that's what I think of it as. Like,
So you're asking if you could ask, or for each core run a different instance of UKL?
right.
So do you want me to take that, Ethan? Or?
I think I'm freezing.
So the general thing is that if the application which is linked into the kernel, can corrupt other applications. We're not protecting other applications from it. So if you have a single kernel running across all those cores, what we do allow is there could be multiple instances of that application running, and they're with different UKL configurations. So as long as they don't, as long as you're willing to, in a sense, trust that one could corrupt the whole thing, because once you're linked into the kernel, you have keys to the kingdom. But that's sort of the same model as, say, anything that requires root to run in, although errors are sort of more likely, I guess, in this. Like eBPF has that same kind of condition, that the person who is running this thing has the keys to the kingdom. But there's a whole series of different configuration options that then improve your performance in different ways and that have different restrictions around them.
I think it's important to say that UKL, what you get out is a VM Linux. It's literally a kernel, so it runs wherever a VM Linux or a kernel runs. So I mean, one way to do the 128 cores thing is to have some virtualization technology.
Or you just have a whole bunch of Raspberry Pi compute modules, and they run one thing, and you
yeah, that's absolutely fine. That's in the case that these are separate computers, then it just works.
But okay, I don't want to take the whole time, but yeah, this was a great talk. So yeah,
Tom, I'd absolutely love to talk to you.
All right.
So maybe in a few days I'll get in contact.
Yeah. All right, that sounds great.
But I think that in a way, just sort of taking it back, just to restate that motivation, is that Linux has invested a lot in this battle-tested code that has this rich tooling and everything else available to it. But there's certain latency challenges in the approach that affect you in sort of data center applications, 99.9% tail latency. A lot of real time is about trying to ensure you get the same performance, but not necessarily optimized performance. Giving fixed priorities to different things. So one of the goal was to sort of say, if we have a critical workload and we're running it on a single machine, can I accelerate, and I'm not running other applications there, can I, instead of saying, forget about the existing implementation, I'm just going to do a new user level implementation on top of DPDK or SPDK or another design, can we end up sort of having that application optimized and linked into the kernel while still keeping it as application code?
Yeah, I'm an easy sell. I believe everything you say has great value. So
if folks are interested, there's a paper
please send me the paper.
So are Ethan's graphs actually in the paper, Ethan? Because it's you gave a whole talk, but no data, right?
So the graphs for secrecy did not end up in the paper, mostly because our reviewers objected to secrecy at that point being not published, and so they viewed it as a proprietary benchmark and something they couldn't reproduce.
I see. Okay, so that's why Ethan is not able to share it yet either.
Yeah.
Got it. It's an unusual talk. That's why I was wondering, because usually we're overwhelmed with graphs here. So Okay. So is there a URL to point people to for the secrecy project yet?
I think there was at least a GitHub page. I don't know
There
if
might
there's a
be, but I'm not
website.
sure that it's public yet, Ethan. I'm not sure that they've posted it publicly.
Okay, we won't
We'd have to
do it then, but
Okay.
do update us when that happens.
Okay.
I did drop the GitHub URL for the UKL project.
Oh, thank you. Thank
so.
you. Yeah. I'll put that in the notes too. Any other questions or comments?
So just very excited for people to have applications for this.
I just want to say thanks, Ethan. That was great as well.
Thank you.
Thank you very much.
Thank you, Ethan.
And you're continuing to work on this project too, right? It wasn't just a summer effort?
I've worked a bit with the team since the summer, but I have not had much time to be fully committed.
Right. Yes, it's the semester again, but we never let go of any interns, you know. Okay, well, it's great to hear from you. Thank you for giving us the story, both you and Arlo.
Thank you.
And we will have another rig investigating other projects next month. Thanks a lot. Bye-bye.